Okay, let's begin then. So, in the last session, we talked about a number of concepts. We started with this in trigonometry that when we have right angle triangles, we have these two things that we can use to find any unknown angles or sides. Number one, we have this Pythagoras theorem. So the sides of a right angle triangle, they're related by this equation. So if we have any one of the three sides missing and the other two are known, you can use this Pythagoras theorem, which says hypotenuse square equals uh, perpendicular square plus base square. Perpendicular and base are the other two sides in any order. It doesn't really matter in this case. So if you have two sides given and you have to find the third side, you can use Pythagoras for that. We looked at this and looked at a few examples on that as well. And then the other thing that we talked about was these sine, cos, and tan functions, which are defined with respect to a right angled triangle. So in a right angled triangle, if this angle here is theta, the side that is adjacent to the angle, we call that the base, and the side that is opposite to the angle, we call that perpendicular. Adjacent and perpendicular, base and perpendicular, they depend on the angle that you're using. If you're using this angle as theta, then the base is going to be the side adjacent to this, which is going to be the vertical side in this case, and perpendicular will be the side that is opposite to it, right? And then once we have defined base perpendicular, then the hypotenuse is always the side that is opposite to 90 degrees. That's always going to be the case. Then we have three ratios defined: sine, cos, and tan, like this. Sine is perpendicular over hypotenuse, cos is base over hypotenuse, and tan is perpendicular over base. Okay, we can use this to find unknown angles, unknown sides in a right angle triangle. So whenever they talk about angles in a right angle triangle, you generally have to use these trigonometric ratios. These were some ways that we discussed to remember the ratios. We looked at some examples. When it's not a right angle triangle, in that case, we have these rules that we can use, the sine rule and cosine rule. They work for right angle triangles as well, but if it's a right angle triangle, using these sine, cos, tan ratios is going to be much more efficient generally. So we only use sine and cosine rule generally when you have triangles that are not right angled. Okay, that means that any of the sides is not does not have an angle that is 90. In that case, what you do is, one possibility is that you can use sine rule to find any unknown sides or angles. When would you use this? You would use this when at least one side angle pair is given. So if you have one side given and the angle opposite to that given, and then you have one other piece of information in the triangle, then you can use that to find the other missing information. This is what we discussed. Then we talked about the cosine rule. After looking at some examples of this, we looked at cosine rule. And the cosine rule was like this: a squared equals b squared plus c squared minus 2bc cos a. When do you use this? Generally, you use this when you don't have any side angle pair given in a particular situation. There are two cases that you would see in this case when you have to use cosine rule. Number one, when you have two sides given and the included angle given. Included angle is the angle between those two sides. So if you have B and C given and the angle between them given, then you can use cosine rule. Or you can have all sides given, and then you might have to find one of the angles that is missing. This is one form for cosine rule that you can use. If you rearrange this, you can also write it like this, with cos A, the subject. Just remember, the side that you have on the left side of this equation, the angle has to be opposite to that side. Okay. We looked at some examples of this, and then we did some more practice from the worksheets that are also uploaded. I hope you've started attempting questions from those worksheets already, because you should complete them over this weekend, all of them. But let's move on to some more concepts for today. So today, what I want to do first is I want to talk about areas of triangles, how we can find areas of triangles using trigonometry, and otherwise that's one thing that we want to do today. And then the concept of bearing, and hopefully we'll be able to talk about the angle of elevation and depression today as well. Okay. Now, while we do this, there's going to be an assumption that you have an idea about alternate angles, corresponding angles, which are angles in case of which are angles that are defined with respect to parallel lines. I'll give you a quick review of that, but we will be doing that next, right after trigonometry, or we might spend some time on that tomorrow. I'll decide that, but I'll quickly give you an overview of that. So the angle properties that you need to be aware of are that if you have a point, then the total angle at a point is 360 degrees, right? So full circle is 360 degrees. Then if you have a straight line, then any point on this line, if you were to find the angle of this line, angle on a straight line, this angle here is going to be 180 degrees, and this angle here is also 180, right? So complete angle becomes 360, but on a straight line, it's 180 degrees. That's another thing that you need to remember. In fact, what I'll do is I'll leave these here. This is what you need to be aware of when, if you have two lines that are intersecting each other like this, then the vertically opposite angles are equal to each other. So this angle here, this is x, this is going to be equal to x, right? So if you have two straight lines, they're intersecting at the point of intersection, the opposite angles are they're equal to each other. These are called vertically opposite angles. X is equal to x in this case, and this angle y is going to be equal to y. That's another property that you need to know of. That's vertically opposite angles. Then in case of parallel lines, if you have two parallel lines that look like this, let's say you have one line like this and another line, or let me actually make them slanted to make it more general. Okay, no, that's not quite working. It's okay. I'll just draw them like this then. Okay, I have a line like this. It's a horizontal line. And I have another line that's parallel to this. Let's say it works like this. It goes like this. These are parallel lines, right? They have the same direction. If these two lines are parallel and there is another line that's passing through, that's intersecting both of these lines like this maybe, then there are some properties with respect to these parallel lines that you need to be aware of that we will be using here. We'll talk about them again in another class separately as well. But if this angle is x, let's suppose if this angle is x, then what other angles are equal in this case? If this is x, this angle is also x. Why? Because these are alternate angles. This angle is also going to be x. These are vertically opposite angles. This is also x because this is vertically opposite to that. All of these angles are going to be x. Okay. These are alternate angles. Okay. Again, we'll talk about that in another class separately, but we might need to use them somewhere here. So I just wanted to give you a quick review of that. Hopefully you have some idea about this already. And then this angle x and this angle x, these are also called corresponding angles. This angle x and this angle x, they're called corresponding angles. These are all x. Okay, so in parallel lines, these angles are all equal. And then the other angle that you've got here, let's say this is y, then this x plus y, their sum is always 180. You can look at it in a number of different ways. One is that this x and y, they add up to 180, but you can also think of a straight line, angle on a straight line. If this is a straight line, then x plus y here, this has to be 180, right? But the idea is the sum of these angles x and y, that is 180. If that's y, this is also y, this is also y, and this is also y. Okay, so you need to be able to figure these angles out, that they're equal to each other. Now, they come from alternate angles, corresponding angles, vertically opposite angles. These are the different properties that we're using here. But you need to be familiar about this. You need to have some idea about this while we do trigonometry. Okay, but we will be discussing these in detail. I just wanted to put that out there. Now, in addition to these, you also have angles in a triangle and angles in any quadrilateral. So angle in a triangle, they are always going to add up to 180. So if you have this angle x, this angle y, this angle z, then x plus y plus z, sum of all the angles in a triangle, that is always going to be 180 degrees. Okay, sum of all angles in a triangle, that's always 180. For a quadrilateral, that means a figure that has four sides, the sum is always going to be 360. Okay. Again, this is part of the angles topic. We will do more details on this on pentagon, hexagon, octagon, so larger figures. We'll talk about some of their angles as well. But for now, we might need to use some of these and just, adding them here. If you have a shape like this, again, it's a random quadrilateral. Let's say it looks like this. Quadrilateral is a four-sided figure. In a four-sided figure, the angles on the vertices, they all add up to 360. So if we know that this angle is x, this is y, this is w, and this is z, then we can say w plus x plus y plus z, that is always going to be 360. Okay, so angles in a quadrilateral, they add up to 360. Angles in a triangle, they add up to 180. Okay, so these are some general things that you need to be aware of. Now that you hopefully are reminded of these properties, let's talk about triangles. So there are some things that we will need to know about triangles when we work on trigonometry questions. Now, what are those different things? First of all, there are different types of triangles that we can have. We already talked about the right angle triangles before. What are right angle triangles? They are triangles in which at least one of the angles, in fact, exactly one of the angles is 90 degrees. But there are other types of triangles as well. Number one, we have a triangle that we call an equilateral triangle. Equilateral triangle. What is an equilateral triangle? It's a triangle that has all sides equal and all angles equal as well. So in an equilateral triangle, all sides and all angles, they have to be equal to each other. So it could be a triangle that looks something like this. It will always have all sides equal, and it will always have all angles equal. Now think about it. The sum of all the angles in a triangle is 180 degrees. If they're all equal angles, then what is each angle going to be? 180 divided by 3, that's 60 degrees. So each of these angles here is going to be 60 degrees. Okay, so all angles are equal and they have a specific value, and that is 60 degrees. In an equilateral triangle, all the angles are equal to 60 degrees. And all the sides are equal as well. If this is x, then this is also x, and this is also x. All the sides have to be equal to each other. That's one type of triangle. Then we have another triangle that we call isosceles triangle. What is an isosceles triangle? An isosceles triangle is one in which exactly two sides are equal. So this should be a triangle in which exactly two sides are equal. If all three are equal, then it becomes equilateral. But if you have two sides equal, This triangle is known as an equilateral triangle. Let me give you an example of one. So it might look something like this. Let's say you have a triangle like this. Okay. Now it's not equilateral. It's obvious that this side here, it's clear from the diagram that the base of the triangle, the horizontal side, that's much smaller than the other two sides. Okay. Now in this case, what's happening is these two sides are equal. And the side on the left side and the side on the right side, these two are equal sides. If I call this x, I can also call this x. Now, in an equilateral triangle, two angles are also going to be equal. So the angles that are opposite to these sides, opposite to this side and opposite to this side, these angles are also going to be equal. So if I call one of them theta, then the other is also going to be theta. The angles are going to be equal. These angles are called base angles. Okay, these are called base angles of an isosceles triangle. Base angles of an isosceles triangle. Which angles? The angles that are equal, the side that is not the same as the other two sides. Generally, we consider this the base of the triangle. Now, it's not always going to be horizontal. It could be some other direction as well. But the side that is not equal, we call this the base of the triangle. And these angles are the base angles, the angles that are equal to each other. So what do we write this right here? We can say exactly two angles are also equal. Which angles are these? These are base angles. The ones opposite to the equal sides. The sides that are equal, the angles corresponding to those sides, they're also equal to each other. Now, a triangle could look like, an isosceles triangle could look like this. It could also be in another direction. For example, you might have something like this, that you have, let's say, okay, so I can't make it like this. I will have to do it manually. So we have something like this, that there is a side here like this. And then, let me see where the third point could be. So let's mark something here. So the triangle could look like this as well. Okay. Now this is a triangle in which two sides are equal. This side is equal. This side is equal to this side. Okay. Now, what are the base angles which are going to be equal? This angle here, the angle opposite this side, and the angle opposite to this side. These these are called the base angles in this case. These are going to be equal to each other. So if you know any one of these angles now, you can find out all the angles of the triangle. How can you do that? So in this case, for instance, if you knew that this side, this vertex has an angle of 50 degrees, how can you find how can you find the angles of the other vertices? You know that both of them are equal. So you can say theta plus 50, that should equal 180. And that gives you 2 theta equal to 180 minus 50. And theta equals 180 minus 50 divided by 2. And the value of theta is going to be 65 degrees. That means the other two angles, they're both 65. Okay. To speed up the process, what you can remember is this, that you will always subtract from 180 this angle. Okay. And then just divide that by 2 to get those base angles. Okay. Because the total angle has to be 180. You have 50 here already. Subtract 50 from 180. What are you left with? 130. You divide that by 2, and that gives you 65 degrees. Okay. So if you have one of those angles given, you can find the other ones like this. In this case, you can also have a situation like this. If I were to just copy this same triangle, and now let's suppose I had something like this given, that these two sides are again equal. All right. However, now what I want to do is I want to find this angle theta. And I'm given that the angle on top here, let's suppose this is 55 degrees. This is what I know. Okay. Now, how can I find the angle theta in this case? If this angle is 55, then what does that mean? This is a base angle of this isosceles triangle, right? Because it's opposite to this side, that is equal. So the angle opposite to the other side, that's also going to be equal. So this angle is going to turn out to be 55 as well. So we can write that this angle here is also going to be 55. So what about the value of theta then? How do you find that? You can say theta plus 55 plus 55, that equals 180. Or essentially what you have to do is subtract from 180 both of these angles. 180 minus 110, that gives you 70 degrees. So the value of this angle therefore has to be 70 degrees. Okay, so that's what happens in an isosceles triangle. Now, there are there's another property of isosceles triangles, and that is that if you have a triangle like this, let me draw that here. If you have a triangle that looks something like this, it's an isosceles triangle again. We're talking about isosceles triangles. If you have a triangle that looks something like this, in this isosceles triangle, if you were to draw a line to the midpoint of the base from the third vertex, if you were to draw a line like this, a perpendicular line from that vertex, this line, if you know that this point is the midpoint, this line is always going to make a 90 degrees here. And it works both ways. If you know that this line is perpendicular, then this point at which it is going to cut the side is always going to be the midpoint of these two sides, of the base of the triangle. So that means this length here on the left side of the right angle and this length here on the right side of the right angle, they are both going to be equal to each other. And this is always true for an isosceles triangle. If you draw a perpendicular from the vertex other than the base of the triangle, so in this case, this was the base, right? The side that was not equal. If it makes a 90 degrees, it will always cut at the midpoint. So you can make two right angle triangles in the triangle, like in the isosceles triangle like this. Now, if I were to rotate that triangle and if I had something like this instead, in this triangle, this is also an isosceles triangle in which two sides are equal. What's the base in this case? Which side do we consider the base in this case? Remember, we said this earlier. The base is going to be the side that is not equal. So which side is not equal in this case? This side here. If I were to draw a perpendicular from the third vertex here to this side, if I were to draw a line that is perpendicular here like this, the base is always going to be divided into two equal parts such that this point is the midpoint. So you get two right angle triangles and these two triangles are kind of equal to each other. The triangle on the left side, triangle on the right side, they're always going to be equal to each other. Now that's not just true for isosceles triangle. Equilateral triangle also has this property. Here as well, in case of equilateral triangles as well, if I were to draw a line from one vertex to any of the other sides. If it's making a perpendicular here, this side is always going to be cut into two equal parts like this. Okay, it's always going to be like this. And the angle is also going to be divided. This angle and this angle, if one of them was theta, the other is also going to be theta. The angle will also be divided equally into two halves. That's true for equilateral triangles. And equilateral triangles, you could draw that perpendicular, you could draw that height from any of the three vertices. You could draw it from here. You could draw it from here as well. This is also going to make a 90 degrees and cut these two angles into halves. You can make a right angle from here. That's also going to cut this side in half. So in equilateral triangle, that height can come from any of the three vertices. In isosceles triangle, like this, there's only one possibility. The side that is not equal, you would consider that side as the base. So in this case, you would consider, in the first case on the left side, you would consider the horizontal side as the base, and you can draw a perpendicular from the third vertex to this base. And in case of the triangle on the right side, you would consider this side as the base because that's not equal to the other sides. And then you can draw a perpendicular from the third vertex to here. If it's a 90 degrees, then the side is going to be equally divided into two parts. I'm sorry, something wrong with OneNote right now. Okay. So that's what happens, okay? This is something that you need to be aware of. If a triangle is neither equilateral nor isosceles, in that case, this property does not apply. So if I had a random triangle which was neither equilateral, neither nor isosceles, I could have a random triangle that might look something like this. Let me draw one. In that case, we can't say anything like that. So let's say we have something like this. A triangle that's neither equilateral nor isosceles, we call this a scalene triangle. Although this name is not that important, they don't generally mention this, but that's another name that you might see in some books. This is a triangle that's neither equilateral nor isosceles. It's not even a right angle. All sides are different, all angles are different. Okay, so what is a scalene triangle? All sides and angles, they are different. In this case, none of those properties apply. If you were to break this triangle down into two parts, or if you were to draw a perpendicular here, you cannot assume that this perpendicular is going to cut this side into two equal parts. That's not going to be the case. If this is x, this is y, x is not going to be the same as y, okay? It does not cut it at the midpoint. In a random triangle like this, do not assume that if you were to draw it perpendicular, it will always cut at the midpoint. That's not going to be the case. It's only true for isosceles triangles when you are cutting at the base, or for equilateral triangles from any side. Make sense? Any questions until this point? These are some important properties that you need to know for triangles, because you will need to use them in questions on trigonometry. Any questions until this point? The different types of triangles, all of you understand that? No problems? All right, good. Now, let's talk about how to find areas of triangles now that we understand how we can work with the different angles that can be there. You need to be able to find areas of triangles in trigonometry as well. Now, how do you do that? Let's discuss the different possibilities you can have in this case. Area of a triangle. area of a triangle. Let's take an example. Let's say you have a triangle that looks something like this. Now it's a random triangle, not isosceles, it's not equilateral. It looks like this. How do you find the area of this triangle? One formula that we have for area of triangle is half into base into height, right? That's what we can use to find area of a triangle. Now, in this case, we are first going to consider a simple scenario. Or in fact, let me start with this case first. Let's say it's a right angle triangle. It's not a random triangle. Let's start with this case that it's a right angle triangle, and that looks like this. Or I could make it even simpler for the first example. Let's say I have an easier looking, a simpler looking right angle triangle like this. Now, how can I find area of any of these triangles? One formula that we have for area is given like this. Area of a triangle is equal to half into base into height. Half into base into height. That's one formula for area of a triangle. Okay, half into base into height. Now, it's very important to understand what base means in this case and what height means in this case. Okay. Because if you don't understand that, you will often end up getting this wrong. What's base? Which side in a triangle can you consider the base of the triangle? That's the question. Let's think about it. Base can be any one of the three sides of the triangle. Okay. Any one of the three sides of the triangle, you can take that as the base. Okay. So in the triangle on the left side, you can take this side as the base. You can take this side as the base. Or you can even take this side as the base. All three sides of the triangle, you can take them as the base. Okay. Now, how does that make sense? It makes sense because then the height that you would be considering, that would then be the perpendicular from the third vertex to the base that you are considering. Okay, now what does that mean? Since we can take any one of the three sides as the base, let's take the different cases that are possible. One possible case could be that you take this horizontal side as the base. If you take the horizontal side as the base, then what is the height going to be? Height is going to be the perpendicular coming from the third vertex. What's the third vertex? We have already used up these two vertices in the base. The third vertex is the one that's not part of the base. This is the third vertex. Height is going to be the line coming from that third vertex to the base that is perpendicular like this. So if you're taking this side as the base, then height is going to be this side. All right. Okay, that's one possibility. Then another possibility could be that you consider this side as the base. That's also possible. Base can be any one of the three sides. So you can consider the vertical side as the base. You can say this is the base. Then what about the height? Height is going to be the line coming that is from the third vertex that is perpendicular to the base. What's the third vertex? This is the third vertex. So the line coming from this third vertex to the base that's perpendicular to it, that's going to be this line. So in this case, this can be considered the height. All right. And then finally, what if we were to consider that hypotenuse as the base? What if you were to consider this length as the base? That's also possible. You can consider this side as the base as well. If that is the base, then height is going to be the perpendicular coming from the third vertex. What's the third vertex? This is the third vertex. Perpendicular coming from this vertex to that side, this would be considered the height of the triangle. Okay, so any of the three sides of the triangle can be taken as the base, but the height then has to be the perpendicular from the third side coming to the base, third vertex to the base. Okay. Now, in this case, in a right angle triangle, the simplest way is to consider one of the perpendicular sides the base, and then the height would be the other perpendicular. For instance, if you knew that this side was 5 and this side was 3, you can say this is the base, this is the height, and the area of the triangle would then be 1 over 2 into 5 into 3, and that is 7.5. In the other case now, let's say we had two lengths given like this. Let's say we knew that this side is 4 and, or let's take some other numbers. This side is 10 and maybe this side is 14. Now the sides that are perpendicular to each other, it's going to be the easiest to take those sides as base and height. So remember, base can be any of the three sides. So I can take this side as the base. For instance, if this is the base, then what's the height? Then height is going to be perpendicular to it. Then this side is going to be the height. Okay. Now, what does that become? That becomes 1 over 2 times 10 times 14. And that gives me 70 as the result. That's the area of this triangle. So in case of a right angle triangle, the easiest way would be to take the perpendicular sides as base and height. So if you know one of them, if you know the perpendicular sides, you take any one of them the base, and the other would be height. Now, remember, in this case, if this base was, let's say, we have to evaluate this 196 plus 100. In this case, the base is going to be 17.2. Not the base, the horizontal side. This horizontal side is 17.2. We're not using that at all here, right? Because it's not necessary that the base has to be the horizontal. It's not necessary that the base has to be horizontal. Base can be any of the three sides. So if you're taking 10 as the base, 14 is height. If you're taking 14 as the base, 10 is the height. Okay. Now in a right angle triangle, it becomes fairly straightforward like this, that we take one of these perpendicular sides the base and the other would be height. But what if it's not a right angle triangle? What if we have a random triangle now? So now let me draw another triangle, which is not a right angle triangle. So let's say I draw something like this. Now this triangle is none of those special triangles. It's not right angle. It's not equilateral. It's not isosceles. How do you find the area of this triangle? Now, again, remember this, base can be any one of the three sides of the triangle. Any one of the three sides that can be taken as the base of the triangle. Okay, there's no restriction there. If we consider this horizontal side as the base. If we consider this as the base in that formula, half into base into height, if we consider this as the base of the triangle, then what is the height going to be? Height is going to be the perpendicular that comes from the third vertex to the base. This is going to be taken as the height. Okay. With respect to this horizontal base. If I were to consider another side, the base, I could also consider, for instance, this side as the base. Okay, then what is the height going to be? Height is going to be the perpendicular that's coming from the third vertex. Now let me use another color so there's less confusion. Let's use green for this. So now we have this base. So I'm taking this as the base now. In the earlier case, I took this side as the base. If I'm taking that green side as the base now, what is the height going to be? Height is going to be the perpendicular coming from the third vertex to the base. It might look something like this, such that this angle here is 90 degrees. This would be the height in that case, if you're taking this side as the base. Okay, so the height depends on which base you're taking. And then it's also possible that you take this particular side as the base. That's also possible. You can take this side as the base. If you take this as the base, then the height is going to be the perpendicular from the third vertex coming to that base now. And that might look like this perpendicular. This would be the height in that case. Okay. So you need to make sure when you're using the formula, you are using the correct base and height. Okay. You have to use the correct base and height. Let's take a few examples in this now. Let's say you've got something like this. You have this triangle, a random triangle. Okay, so we have a triangle like this. And we know that the sides are like this. Let's say this side is 7 and this side might be 9. And we know, or let's say this is not known, we know that this is 10. And we know that this perpendicular here, that is equal to, let's say, 8. Now, how do you find the area of this triangle? How do you find the area of this triangle? That's the question. Which sides do we use? Do we use 7 and 10? Can we consider 7 as the height and 10 as the base? No, they're not perpendicular. We cannot do that. Remember, base has to be one of the sides of the triangle. Base has to be any one of the 3 sides of the triangle. Now, we have 2 sides of the triangle given. One is this side, this is 10. If we consider this side as the base, then what is the height going to be? Height is going to be this length here. If we consider 10 as the base. Now, do we have that height with respect to 10? We don't have that. Okay. However, if we consider this side as the base, the one that is 7, do we know the perpendicular in that case from the third vertex? Yes, this is known to us. So the base that we use has to be 7. So the area of the triangle is going to be given by half into 7, which is the base of the triangle, times 8. 56 over 2, that's 28 square units. That will be the area of this triangle. Okay. Now, sometimes what can happen is the base of the height of the triangle can also be outside the triangle. Let me give an example of that. Let's say you have a triangle that looks like this. So we have this, and we have this, and the triangle looks something like this. Okay. Now let's suppose we are given the coordinates of the vertices of this triangle. Let's suppose that this point is 10 and 12, and then this point here is 5 and 6, and this point is 1 and 6. So we know the vertices of this triangle. Can we find the area of this triangle? What's the area of this triangle? Can we figure that out? Which side do we take as the base? Which side do we take as the height? If we take this side as the base, the horizontal side, do we know the length of this side? We can find that, right? Because this is x equal to 1, this is x equal to 5. You've done coordinate geometry. What's this distance going to be? From 1 to 5, this is 4 units, right? So this length, the base is 4 units. Now, if this is the base, if you're taking this side as the base, what is the height going to be? Height is going to be perpendicular to this, the perpendicular coming from the third vertex to the base. Now, this is the third vertex. If we draw a perpendicular from that third vertex to the base, where is that going to be? So this base is horizontal, perpendicular to that means a vertical line. If we draw a vertical line here, that is going to be outside the triangle, okay? And that is possible sometimes, that the height of the triangle is outside the triangle. This would be considered the height of the triangle. We would extend the base outside. The point where this perpendicular to the base meets this line, the height is going to be until this point. This is the height of the triangle. Now, do we know what the height of the triangle is in this case? Yes, because we know that this y coordinate is 6. This y coordinate is 12. What's the difference between 6 and 12? It's 6 units. So the height of this triangle, therefore, is supposed to be 6. Height is going to be 6. Base is going to be 4. So now we can find the area of the triangle, half into base into height. Let's see what that turns out to be. Area is half into base. Base is 4 times the height, which is 6. 24 over 2, that gives you 12. That's the area of this triangle. Okay, so sometimes we can end up having the base of the triangle outside the height of the triangle outside the triangle as well. Okay, base has to be one of the 3 sides. Height sometimes might be one of the sides, or it might not be a side. Like in this case, it's not any one of the 3 sides. Now it can happen in case of triangles like this. It can also be some other triangle. For instance, if I were to draw another triangle that might look something like this, let's say let's draw something else. Let's say I have something like this. So I have this triangle now. Okay, let's say this is A, this is B, and this is C. Now, if I consider this side as the base of the triangle, let's suppose I know the length of this side, and I consider this as the base of the triangle, let's suppose. Then what is the height going to be in this case? If this is the base, the height is going to be the perpendicular from the third side, from the third vertex, from the third point to this base. Again, this is outside the triangle now. Base is only this yellow part. You're not going to extend the length of the base because of that. The length of the base is just this much. But then the height is going to be this length here. We will consider this as the height of the triangle. Okay. So just need to just need to understand that sometimes the height of the triangle can be outside the triangle as well, like this. Okay. All right. So that's important. That these are some important concepts to understand as far as using this formula is concerned. Area of a triangle is half into base into height. Base has to be one of the three sides of the triangle. And then height is going to be perpendicular from the third vertex, from the third point to the base that you're considering. Okay, now that's one formula that we can use to find areas of triangles. That's one formula. Sometimes you would not have the height given, or you would not be able to find the height in a context. What do you do in that case? In that case, you have another formula for area of a triangle as well, and that looks like this. Area of triangle is also given by half into A, B sine of C. That's another formula that we have for area of a triangle. Now, what does that mean? What's A, what's B, and what is C? Let's understand that A is one of the sides of the triangle. So you can say this is side one. Okay. B is another side of the triangle. Let's say that is side two. Into sine of C. What is C going to be? The triangle is going to look like this. If the triangle is, for instance, ABC, if I were to draw a triangle like this, let's suppose this was a triangle, and this is, let's say, A, this is B, and this is C, like this. Okay. Now, if we know two sides of the triangle, so remember the sides are going to be like this. The side that's opposite to A, we call that small a. The side that's opposite to B, we call that small b. And the side that's opposite to C, we call that small c. Now, you can use this formula when you have two sides given, A and B. It could be any of the three sides, any two of the three sides, and the angle between those two sides. Angle between those two sides. The C is going to be the included angle. Right? We already talked about included angles before. What's an included angle? Included angle is one that is between two sides. Angle between the two sides. So what's the formula like? It's 1/2 into side 1 into side 2 times sine of the angle between sides 1 and 2. Okay? Sine of the angle between sides 1 and 2. That's what the formula looks like. Okay? It's one side, it's the second side. C is the included angle. That's what you'll be taking the sine of. Now, let's take some examples. Let's consider a triangle like this. Now, in this triangle, let's suppose you knew all three sides. Let's say this was A, this was B, this was C, and the angles are then A, B, and C. The vertices are then A, B, and C like this. Now, how can you write that formula? It depends on which sides and which angles you're considering. If you're considering A and B as the sides, then the angle between them would be this. So one way to write the formula of the area of the triangle would be half AB times sine of C. But instead of that, if you were taking some other sides, now that we understand what the formula means, we can take any of the three sides. You can also write it like this. You can say, okay, what if I take B and C as the two sides? Now you can also do that. If you take B and C as the two sides, which angle are you going to consider in that case? The angle between those two sides. And what's that angle? That is the angle A in this case. That's the angle that you would consider. So you'll say it's BC sine of A. Okay. If you were to consider these two sides, A and C, that's also possible. You would say the sides that you're considering are A and C, and then the angle has to be the one that's between those two sides, and that is B. So we have AC sine B. That's what the formula becomes in this case. Okay. So it could be any of these three different forms that you can use. This is what you need to remember. It's any of the two sides, but then the angle that you consider has to be the one that is between those two sides. Okay, that's important to remember. Now let's take a couple of examples. Let's say I have a triangle that looks like this. So I have this triangle. And in this triangle, I know that this angle here is 55 degrees. And I know that this side is 7 and this side is 11. How do you find the area of this triangle? Area of this triangle. What's that going to be? Half AB sine C. So what does that look like? You'll say 1 over 2 into the two sides that you know. They are 7 and 11. So you can say 7 times 11 times the sine of the angle between them. Do we have that angle? Yes, we know that this angle is 55. So we can use that angle. We can say it becomes sine of 55 degrees. Now you just put this on a calculator. You will get this in the calculator paper. Otherwise, you can't evaluate sine of 55. How do you do that? Just put this on a calculator. 1 over 2 times 7 times 11 times sine of 55. And that should give you the result. The result turns out to be 31.5. That's the area of the triangle that we were looking for. Okay? Make sense? Let's take another example. Let's say you had a slightly different triangle this time. Let's give you something like this. Or let me just copy that. Okay, so now you have another triangle. And in this triangle, you are given one side, and that let's say that one side is 15 here, and you're given another angle. Let's say this angle here is 45 degrees. This is the angle that you're given. And you're given another angle, which is, let's say, this angle here. And let's say this angle is 85 degrees. So you're given one side of the triangle, and you're given one angle in the triangle as well. In fact, two angles in the triangle. Let's say we want to find the area of this triangle. Now, how can we do that? Now, generally, they will divide it into multiple parts for you, but let's see if we can figure this out directly. What is area of triangle given by? Half into base into height. In that case, we need the base and a perpendicular side. In this case, we don't have any of those, of those pieces of information. In fact, we have one. We can consider 15 as the base, but we can't find the height that way. If we want to use the formula half into AB sine C, what we need for that is two sides in the triangle and the angle between them. The problem is we have only one side. Can we find one side of the triangle somehow? We can find one other side of the triangle because we have two angles given and we have one side given. And we have a pair of side and angle given, right? Now, this will be a more complicated example. So what you want to do is you want to figure out what the area of the triangle is. That's the question. Now, how do you figure that out? We'll have to think about it. If you want to use the formula half AB sine C, we also need another side. You have one pair of side and angle given, and you have one angle given in the triangle as well. Can you find this side somehow? You can use sine rule to find this missing side. Okay. How can you find that? You can use sine rule for this, right? Let's do that. Let's call this side x. We can say x over sine of 85. That should equal 15 over sine of 45. Okay. X over sine of 85, that equals 15 over sine of 45. We can use this to find the value of x first of all. Let's see what that turns out to be. 15 sine of 85 divided by, so this will go to the other side, right? Get multiplied. Let me write that down here as well. 15 sine 85 divided by sine of 45. What does that give us? This gives me the value of x, which is 21.13. So what I've done now is I found this missing side as well. Okay. Once we have done this, once we have found the value of x, now we know that this is 21.13. So now we have two sides of the triangle. One was 15, that was already given to us. And what we've done is we have used the sine rule to find another side of the triangle. So now we have two sides of the triangle. Can we use the formula now? What's the formula? Formula for the area of the triangle. We can say area of triangle is given by half AB sine C, which means two sides and the angle between them. So we have two sides given. One is 15 and the other is 21.13 that we have just found. What about the angle C? What's going to be the value of angle C here? Any idea? What's the angle C going to be? Can we figure that out? Yeah. This is supposed to be the angle that is between these two sides. What's the angle between these two sides? It's this angle here. Now we know the other two angles. We can find this. How do you find that? By subtracting from 180. So you can say 180 minus 45 minus 85. That gives us 50 degrees. So this angle here is therefore supposed to be 50 degrees. This angle is going to be 50 degrees. That's the angle that you would use in that formula now. You'll say it's sine of 50 degrees. We're using this side, and the angle between them in the formula. And that should give us the area of the triangle. You just put everything here in the formula and see what that gives you. Times 15 divided by 2 times sine of 50, and that's giving me 121.4. That's the area of this triangle that we're getting. Okay. Now I can just put this like again here 1/2 times 15 times 21.13 times sine of 50. So you just have to put this whole thing on your calculator, and that gives you 121.4 when you round it off to one decimal place. You can round it off to three significant figures further, uh, because that's what they generally recommend in the paper. So say this is 121, that's the area of the triangle that we were looking for. Okay. So these were some important concepts as far as triangles are concerned. You need to know about the different types of triangles: equilaterals, isosceles, right angle, and then this property is important that when you make a right angle here like this, in an isosceles triangle, one side is divided into two parts. The base is divided into two equal parts. And then area of triangle, we can use half into base into height for that, and also half into AB sine C. This is the second formula that we have. The two sides that you use in this formula, they can be any of the two sides, but then the angle C has to be the included angle, the angle between those two sides. Okay. Now, I wanted to cover bearing today as well, but we're running out of time today, so it'll be a rush if we do that today. So tomorrow, what we will do now is we'll talk about bearing. We will cover the concept of bearing, uh, and the concept of the angle of elevation and the angle of depression. Now, those are two small things in terms of concepts. However, they will require us to do a lot of practice because the questions on those two concepts are sometimes complicated. So what we'll do tomorrow would be that we will discuss those concepts in the first 30 minutes, inshallah, and then the remaining time we will spend on doing practice questions. Okay, so that's for tomorrow. I would recommend that you start attempting questions from the other worksheets already. So bearing and the questions that involve angle of elevation or angle of depression, you can skip those for now. But most of the other questions, they should be doable for you now. You should be attempting those from the worksheet. And then we'll discuss some of them tomorrow as well, inshallah. Okay. So that's it for today. If you have any quick questions, you can let me know. Otherwise, we're going to end this here. Any problems, anyone? Any questions? No. All right. So I'll see you again tomorrow then. Allah Hafiz.